Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers, and it's actually easy if you know the trick. Imagine a student who drew the diagram, wrote down one angle, and left the rest blank. That single missing reason cost them 3 marks. Sound familiar?
Oh, absolutely. I feel that. You can see the answer in your head and still lose marks because you didn't write the reason.
Exactly. Today we're fixing that with one simple angle chase routine that makes circle questions predictable. No more guessing which theorem to use. Instead, you follow a checklist and write the short, examiner-friendly reasons the examiners actually want to see.
The concept, step 1, the routine itself. Start by labelling, then link equal arcs to equal angles, then use cyclic properties if you spot a quadrilateral. I'll walk you through a single worked example and explain why each step is valid. Step 1. Label everything. Mark the centre if it is shown, mark the points A, B, C, D, and draw the relevant arcs. If the question gives an angle, like angle ABC equals 40 degrees, write it next to the angle on the diagram. A labelled diagram is your first method mark.
So, even if the question prints a letter, you should rewrite that value on the diagram.
Yes, write it on the diagram. Write it big. Examiners love a labelled diagram because it shows you understand the setup. That's M1 territory. Step 2, look for angles in the same segment. If 2 angles stand on the same arc, they are equal. For example, angle ABC and angle ADC, both standing on arc AC, will be equal. State it, angles in the same segment are equal. Short, precise, and correct.
Why is that true? A quick reason: both angles subtend the same arc. They intercept the same chord, so they must be equal because they subtend equal parts of the circle. You can say angles in the same segment are equal, and that's examiner-friendly English.
And step 3 is the cyclic quadrilateral idea, right? Opposite angles add to 180 degrees.
Exactly. If the 4 vertices lie on the circle, the opposite angles are supplementary. Right. ABCD is cyclic if the diagram shows all 4 points on the circle, or show it by argument. Then write, opposite angles of a cyclic quadrilateral sum to 180 degrees. That's your reason. Again, short and precise. Don't elaborate. Examiners prefer concise mathematical reasons.
Let's work a full example through the routine. Imagine a circle with points A, B, C, D on the circumference. You're told angle ABC equals 60 degrees, and the question asks for angle ADC. Step 1. Label the given angle on the diagram. Write 60 degrees next to angle ABC. Step 2. Identify the arc. Both ABC and ADC stand on arc AC, so angle ADC must also be 60 degrees by angles in the same segment. Write the reason next to your working. Angles in the same segment are equal. Step 3. If the question also asks for another angle, say angle BAD, and ABCD form a cyclic quadrilateral, you can use opposite angles sum to 180 to find it.
So the working you'd write in the exam is basically angle ADC equals 60 degrees, angles in the same segment are equal. That would get the marks.
Yes, M1 for the labelled diagram and writing the equality, M1 for the method, the angle equality, and A1 for the final angle value. If you add the reason phrase, the examiner can award the full marks even if your handwriting is messy. Let that sink in.
Now, the exam technique, how marks map to steps. A typical 3-mark circle question is split like this. M1 for a correct labelled diagram or a correct equation relating angles, M1 for the correct method or intermediate result, and A1 for the final answer with units or degrees. If a question explicitly asks prove or show, expect the examiner to look for short reasons at each step, not paragraphs, but a reason for any equality you use.
What are the two most common reasons students lose marks in these questions?
Good question. Number 1, unlabeled diagrams. Students do the angle arithmetic in their head and write the answer without showing the diagram. That's a lost M1. Number 2, missing a reason. They write x equals y without saying y. Examiners commonly write reason needed in the script, so always attach a short theorem statement to your equality. For example, angles in the same segment are equal, or opposite angles in a cyclic quadrilateral sum to 180 degrees.
Also, when you use the centre or radius facts, be explicit. If you infer an isosceles triangle because two radii are equal, write radii equals triangle isosceles, and then state the base angles equal. Short phrases like that win marks because they show chain of reasoning.
The quick win, a 3-point checklist you can use in every circle question. Number 1, label the diagram and write the given angles on it. Number 2, write the relevant theorem in 3 words: same segment, cyclic opposite, or radii equal. Number 3, attach the short reason to your working line. Here's a 10-second sanity check. After you finish, look back at your diagram and write the arc or equal angle used, state the theorem name, and then tick your answer. Do that and you'll catch around 90% of silly errors.
That sounds doable under exam pressure. Write the arc, say the theorem, tick the answer. Quick and repeatable.
Exactly. That's a grade 9 move because it turns knowledge into a reliable habit. Don't skip the check. Write it down. Don't just think it. Outro. Quick recap and where to go next. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable angle chase sheets at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious. Extension practice. One short variant to try now. Suppose you're given a circle with chord AC and 2 angles at the circumference. Angle ABC equals 50 degrees and angle ADC equals x. If B and D lie on the same arc AC, then x equals 50 degrees by same segment. If instead the diagram shows ABCD as a cyclic quadrilateral and you're given angle ABC equals 50 degrees and asked for angle ADC, you must use opposite angles sum to 180 degrees. Angle ADC equals 180 degrees minus 50 degrees equals 130 degrees. In exam language, you'd write ABCD is cyclic, opposite angles sum to 180 degrees, therefore ADC equals 130 degrees. That's the exact wording examiners prefer. 3 quick tips for teachers and parents when guiding practice. 1. Insist students always label the diagram before doing any arithmetic. 2. Mark for a reason phrase as well as the final answer. 3. Give small timed drills where the only allowed evidence is the labelled diagram and one reason sentence. Those drills build the habit fast. And if you'd like 50 worked solutions covering circle theorems and every topic we discuss on this show, you'll find them at jcacademyonline.co.uk. That's your angle chase routine. Label, link, reason. Marks are there for the taking. Stay curious.